Thank you. Hello and good afternoon, everyone. First of all, a little bit introduction about myself. My name is Hayder, and I'm from Pakistan. I was born there. And around 10 years ago, I came to Australia to do my PhD. I'm not a marine biologist, or I don't have a background in biology, but I'm a machine learning guy here. I did my PhD in computer vision and machine learning. And the kind of the work we do here is like mostly object detection and segmentation. So we are working on different sort of applied AI things. So our AI methods can be used not just for like the, you can say underwater applications, but we are also using on the land and on the space as well. Because the similar methods are being developed and it can be applied like for across like different sort of applications here. And those are the things, new technologies that I want to discuss here. So that's why our topic is actually application of new technologies to coral reef monitoring and COTS detection. So what are the problems that we are actually trying to solve here in this scenario? So when we look at this COTS detection thing, the first challenge is that how can we solve this whole problem efficiently and accurately, and we can scale this thing onto like multiple sites and multiple locations, and without the need of any intervention from humans sort of thing. So that is our like first task, and how can we like train some AI models that can resolve, that can do all of this object detection automatically. Second thing is that all of these existing methods that were like developed in like last 40 years, they use some sort of control from humans, like for example, these Metato methods that are being used these days. They require some experienced and trained observers. So it is like too much reliant on human at the moment. And also, these methods cannot be used in areas which are like pest-infected areas due to some safety issues. So what are like more safe ways to monitor and document all these sort of COTS outbreaks? So there come these all these new technologies that we can use. Okay, so in this scenario, what kind of technologies that we can provide that can help all of these COTS detection things? So first of all is that we have like 3 different parts to our work that we are doing. So first thing is that we are using a towed camera platform that we are developing with the help of AIMS. So AIMS is developing a platform that is like much faster and very safe, and it can only require like much less number of trained observers so that they can operate it themselves. Secondly, is that how we can develop some AI and machine learning technologies that can identify COTS and scars in the images. The main goal in this scenario is that we need some instant feedback for the observing team, and how we can reduce it and remove the need to manually analyze the images. So, for example, we have like a much bigger area, and if we can like capture the video and do all this analysis on the boat itself, on the vessel, in the real time, so those kind of technologies can be very helpful in this scenario. And thirdly, it can also provide some actionable information that can help the culling work and different monitoring teams work as well. And the third thing is that how we can use this cloud computing and data workflows in order to consolidate and deliver results in like much more consistent manner. For example, it will help to reduce the workload of the existing data collection and data backup methods. Also, how we can simplify these reporting things and ensure that everyone can be using the same sort of data that we are collecting. And also, if we can make these data public, it will be very useful for other computer vision or machine learning scientists so that they can use the same images and develop much better methods for the future. So here is like a simple real-time workflow that we are working on. So we have a vessel and an operator is actually controlling that thing, and we have a towed autonomous platform, which is like attached to the vessel via cable. So this cable is actually transmitting the data and control from that one to here. And actually, it is actually detecting COTS and the scars real time, and it is providing that feedback to the observer on the vessel. So as I discussed earlier, that we have 3 components in our system. So the first component is this new towed platform. So Ames is actually developing this one. This platform consisted of like a small camera which is tied to the front of the platform, and it is actually doing 2 things. One is that it is providing images to the operator so that it can steer this vehicle and it can see some obstacles which are in front of this one, and he can like maneuver this thing. Second, he can actually control the altitude and depth of the vessel, for example, in order to have like a better clear view of the scenarios. Third is that all the images or data that we are collecting from this platform is actually GPS tagged, so that we can exactly see that, okay, which location has like more COTS and like scars in the images. So on this platform, we have like a small AI computer, which is actually doing analysis on board. So it doesn't need to transmit all the images or videos back to the cloud or do some offline processing. No, it can do all of those sort of object and cost detection on this towed platform. So the operator is being provided with a small tablet where he can see the images, and he can also see the counts of like how many COTS are being detected. So it is not just like taking one COT, it is actually tracking all of those COTS there so that we don't do the double counting of any of those detected COTS. And it can be used in like many pest-infected areas as well. Like it is very safe to operate there. Here is like a small video of our platform that we are developing. If you will see that there's a yellow cable attached to this one, which is being used for control and data transmission. However, all of those AI is being deployed onto this platform. So, so it has these 4 thrusters on all the corners of this one, which can help stabilize it and like do the control of this one. So this is the images and videos that we are actually getting in real time, and we are processing it on board. And the small video is actually the one that the vessel operator is being using to control and steer this platform. Yeah, so you can see that we can like have a like much better color or you can say images of this area. So we have collected this data across several reefs near the Townsville and as well as the Swains area. So, yeah. So the second component is actually real-time AI for COTS and scars detection, and this is the main driving thing, that how we are actually doing this thing automatically. So the as I already told that the towed platform includes a small special sort of computer which is doing images and videos detection automatically. So the kind of analysis that we are doing on board is that it can actually see how many COTS we have already detected, presence of any sort of scars, and we are focusing only on like COTS scars in this scenario. And it can also calculate like what is the percentage cover for the coral in the images that it is collecting. And also the detections are being presented to the user, and they can validate them. Because some of those machine learning model, it can make some mistakes. So we have operators to validate that, okay, so the objects are actually really COTS or not. So in order to develop these models, we are using data, which is like the main driving force behind this thing. So we developed a computer vision annotation tool that that our marine biologists are helping us to annotate the images. If you can see in these images, we have like very two small codes. So our annotators are helping us to annotate these boxes initially. And then what we are doing is that we are actually training our own model. So for our, like for example, 5 minutes video, we are only taking few sample images in those videos, and those sample images are being annotated by annotators. And then for other images, we are actually using our computer vision model, machine learning model, in order to capture and detect all of those COTS in remaining images. And then these remaining images are actually being provided to some expert annotator, and he can actually see that, okay, so few COTS are like true positive, or they are like false positive one. So they can curate these things. And here is some results of our machine learning model. As you can see that there are like some boxes popping here for different sorts of COTS as soon as it detects. And this is the kind of thing like it operates in real time. And even though you can see that the video is not very stable, but our model is still able to detect like the COTS in real time here. Similarly, we developed a model for scars detection. For scars, we are actually using not just boxes, but we are also developing a semantic segmentation-based model. So in this scenario, we also provide these images to annotation experts, and they are actually labeling these areas that, okay, so these are the kind of scars they are interested in. For the scars, we also have like different sort of subcategories for them. So for example, these are like a bleaching scars or core scars or like drupula, these sort of ones. So however, when we develop our machine learning model, we are only focusing on core scars. And if you look at this image on the left-hand side, is the output of our model, and on the right-hand side, you will see the ground truth that our annotators have provided us. So you will see that the scars are like much harder in order to detect and track here. However, our method is like initially providing some more false positive in this scenario. Yeah, sure. Thank you. Okay. And this machine learning model is only in proof of concept phase, but it can still provide like a very good initial estimate that, okay, so which areas are actually being detected as more scars. So the third component in our model is actually how this data workflow can be used in an overall system. So all the data and the detections are being saved in this CCIP information system, and it is being used for the reporting purposes. Secondly, that all the images that we are capturing on this onboard vessel platform, we are actually saving them later in this AIMS Reef Cloud system for any post-trip image analysis thing. And also the AI models can be refined further in the future in order to have to increase the accuracy of our systems, and how we can evolve our models later on, and that can be applied as well. So, finally, what are the main take-home messages from this project? First of all, is that these new technologies, especially computer vision and machine learning, has the ability to automatically detect and monitor large-scale areas, and it can actually work in a like much efficient, much better manner. Secondly, it requires like much less human expertise. They are required during image annotation, collection, sort of thing, and also just for verifying that the model is running properly or not. Second thing is that data is like very important, and then all of this sort of analysis, how many COTS, how many scars, which areas are they present, they are like saved in like a proper systematic manner, and we can generate reports based on that. It also provides a better safe and efficient way to analyze large-scale areas. And also we have seen that there are like easier pathways to get like a permanent record for any kind of reefs and for future understanding. And finally, that it gives a pathway for new technologies to be taken up and used as it is. All right. So I would like to thank our partners in this project, especially AIMS and the GBRF. I also would like to thank the COTS Control Team, especially the Blue Planet Marine and Pacific Marine Group and INLOG. Thank you.
Thank you very much. Huge breakthrough. We probably have time for one really quick question. Yeah, Rena?
I'm the only one asking questions. Thank you. Do you have any validation data in terms of what the accuracy goes for or anything like that for the code detection?
Yes.
So the question is for the tape. Are there any validation data available?
Yeah, thank you. So for all the trips, what we usually do is that we capture, we use like 80% of the data for training, and we always take like 20% of the data as a validation set. So our annotators are providing annotation on those images, and then we check our accuracy on those validation data sets. So, however, on the validation data, usually our accuracy is like very high, but the main thing is that how this thing works in the real world, that is like the main thing. And actually AIMS can provide those numbers. I cannot actually, yeah, thank you.
Okay, thanks very much, Sihan.